Okay, we're back. Um, Part three, matrix calculus. Um, we're doing the neural network today. I'm not gonna bother with doing the logistic regression multi-headed first. We're just gonna go straight to the neural network, and um, I have a feeling we're not gonna get to the LLM. I'm quite tired. Um, it took an hour and a half to fix the iPad. Um, I'm upset with vibe coding. Dangerous game at times, you know. How do I say? I can only imagine. Oh my goodness, yeah. I can only imagine being like a back end engineer for like a quant firm or something. These, I don't know. I guess like latency, like streaming things. You know, it's not as seamless and consistent every single time as something that's running locally on your machine. And so the fact that the drawing pad, it just breaks too much and can really ruffle your feathers. It's ruffled my feathers tonight, guys. Let's see. We have our indicators already. There we go. Oh, you can't see all of them for some reason. Do I need to go wider or do I need to go narrower? It's got to be one and not the other. Oh, actually, I need to shift. It's possible that it's one of those. Okay. So we've got our 4 points. We've got Volchat open. I actually might take this back in the sense that I don't think we're gonna have Volchat open yet. Our goal is to internalize this. Has to be, yeah, that's LLM. Our goal is to internalize this. I had started that towards the end of the last video, um, and we're going to like independently converge to this, even though this currently makes no sense to me. But we're going to realize why this is something. So I'm not full screen. This is full screen. I don't even think I want it full screen. Let's see. I have to exit full screen. Yeah, I would rather expand it all the way out, and then you can see me. Sure. Oh, but that's kind of an interesting problem. Is this still doesn't match the aspect ratio of the iPad? You can't see any of the corners. That doesn't make any sense. Sorry about this. That's so strange. So I should actually make it fit. Yeah, it perfectly fits my actual laptop video ratio. So that's what I'll go with. Strange. So you guys can only see up to like here. Yeah. Okay. Whatever. Um. Yeah. Straight into it is so let's do size 6 and what do we have? We're doing scalar loss for a neural network. Let's draw the neural network. Let's do this. This is nearly unproductive. Like, how useful is it to have a drawing of the neural network? Like, literally, who cares? Okay, this is X. This is, what's it called? Our multi-layer perceptron? I don't know. I don't like that. I don't like multi-layer perceptron. Confused. It's confusing for me, even though it's just what a neural network is. Um, how to say? This is, mm, yes. In terms of our model, this is A1. A1, and then this is crap. This is A2. And yeah, we're going to get into the weeds. So let's go down to 4. Yeah. So what's it called? loss. We're going to do mean squared error because its derivative is super easy. We have a sum across a21, a22, okay? What's it called? So we're going to do the sum of the mean squared error across those two. And then because we have the single variable middle ground ones, we can then, again, this latency that you're seeing, I'm a huge not fan of. Let's see. Dude, I don't know what's causing it. I can't stand it. Um, I think I'm gonna have tangent because I was just fixing this, man. Um, I don't think, how do I say it? Fable can't like fix these things on its own because it sort of like needs feedback from the iPad, really, which really sucks. I would like to just give it a goal and tell it to like make sure that it works, but like, how do I say it? If there's no information in that loop, there's no way for it to test. It's just gonna do reckless stuff. Um, so that really sucks. Um, let's see. Let's go for it. Let's start with L. I had really written it really well last time. I was like really proud of it. We had our goals. All right, and we want, but yeah, before we even had the goals, man, what a shame that we lost that. Because like everything was spelled out. It was actually going to be an amazing flow state thing. So we have L equals the summation from J equals 1 to M, because we're going to do this generically. So this is M, and this is D. D. It's a shame. And because I'm writing on my iPad, I'm not even appreciating how like out of sync it is looking at this here. That's almost good for me. Is like I'll practice the YouTube video and I just don't see that the video is like actually bad, which really sucks. We're going to go with Y. Interesting. We actually have to do YJ. Did I write that last time? I wonder. YJ A2J. Perfect. Perfect. So we could do has big of a input and as big of an output, but we're um and I'm pretty sure as big of a hidden layer, presumably. Um, the only thing that we're constrained to in the way that I'm designing this is that there's like only a single hidden layer. I wonder how well this generalizes. If there's just one more indexing thing that you can do to generalize my solution across hidden layers. I feel like there is, but I don't know it as of now. So we had done it horizontally, is we have A of 2 equals sigma of z of 2. And we're going to start this now, I guess, is I'm going to say z of 2 here as well. For the sake of notation, is that like if it's a superscript in parentheses, it's a layer. So this is the non-activated output of the second layer. Perfect. And then z2 equals w2 z, nope, not z, w2 of a1 plus b2. And then, yeah, I'd even done the dimensions. So like L is a scalar. Oh boy. L is a scalar. What else are we working with? So A2 is a vector. But it's not just a vector. What were its dimensions? Ooh, are we defining things as rows or column? Row vectors or column vectors? I feel like column vectors are classical, which would be m by 1. So that means that z of 2 must also be m by 1. A column vector, it must be, right? A column vector times a matrix is still a column vector. How do I say? W2 is going to be h by no. It's going to be m by h, which means that a1 is h by 1, which makes it a column vector. So let's see. W2 is m by h, and a1 is h by 1. That means b2 is still m by 1. And then we can keep going. What's next is a of 1 equals sigmoid of z of 1. And then z of 1 equals w1 x plus b of 1. And then naturally, w1 is m by d, x is d by 1, and then b1 is m by 1. Okay, so that's our table of dimensions for everything. This is our drawing of our neural network. Maybe we are referring to it. Maybe it is of use. What's going on? Again, just so delayed. And I'm not able to make sure if you're seeing what I want you to see. I've moved my screen. Do I have to write for you to note to see that shift? Look, I've oh my goodness. Guys, this is like not looking good right now. How do I say? I've moved it to the bottom left of my screen so that my camera here, right here, is not covering it. What the heck? How far behind is it? Do I need to like draw squiggly lines? So I just suddenly lost it. I just have nothing. The how do I say? The thing for me to overcome right now is that unlike last time where I called the video because I lost what I was working on, I'm gonna keep going. The phone camera is completely fine. Back in the old days of these videos, I wrote on a regular whiteboard. I didn't have the iPad. So I will continue to write on this iPad and you will just not be able to see what I'm writing. And I apologize for that. But I have had this squiggle drawn for that whole period of speaking and you guys still don't see it. So let's see. Ridiculous. Do I give it another chance? We'll give it one more chance. And if it just disappears again, then it's useless, you know? That's so out of sync. Ridiculous, man. Man, I hate vibe coding, bro. I take it all back. I'm not a big fan. I take it all back. I'm not a fan of vibe coding. Okay. Yeah, no. Okay, I'm gonna turn on the lights and I'm just gonna talk. I'm gonna talk about what I'm writing on my iPad. No one watching this video is going to be able to follow, and that's truly a shame. Hold on. I guess that the middle ground, better thing to try is like, I don't know, continue for me a few things. I continue the exercise of speaking as if I'm presenting it for the YouTube video for the sake of future videos. Um, and then I just ignore the fact that it doesn't sync, but in the event that it randomly syncs, which practically is not of substance for a viewer, but in the event that it syncs, if someone was crazy enough to actually watch all this, they can see instances. All right, and that seems to be synced. Okay, we have everything all the way across to x. So let's do like a fake forward pass. Is we give our input x, it gets multiplied by w1, that gets added. Let's see, x1, we get an m by 1 vector plus b1. Then we add that, which gives us z. Then we activate that, which gives us a, and then we multiply that by w, add b again, we get the new z, activate that. That's our final outputs. All these activations are element-wise on the vectors, so nothing's changing on shape. And then we do, our loss is the difference in the y. We're assuming every data point, this is still for a single data point, but it's still like a vector. So like, yeah, I guess, I don't know, that's a little bit weird, is like, there's a vector x and is being compared to a vector y. Yeah, no, that's completely fine. It's like, even if it was like logistic regression, like multi-headed logistic regression, it's like a silly way to do it, but you could totally do it where you have your input x and then like just what are the three independent of each other logistic regressions that you want to perform on this same data point. Yeah, you could totally do that. You could just do more advanced logistic regression for M heads. Completely fine. It can all be sigmoid. Sigmoidal. And then the fact that you're doing it together, I don't know, the linear algebra-ness. Yeah, I am curious about what information blends and doesn't blend. Because when you do say a trivial matrix multiplication, there's no overlapping. Things line up perfectly. There's no questioning of that. So it's not like, row 2 and row 1. There's no stage in which they like overlap. They're going to be exactly mapped to their respective column in like sort of isolation. That's not true. I'm completely lying because row 2 is going to get a dot product with every column. But still, it's not a good blending, I'm pretty sure. Even though I did make a very incorrect gross statement just then. So, okay, so we have a forward pass, okay? And we're representing in this form to make the calculus for the back pass a lot easier. So, what are our goals? And importantly, this is for the neural network, so we're doing good. So, goals are to get the partial derivative of L with respect to W, and let me jump ahead, it was W2 that we want to do first. The partial derivative of L with respect to B2, and then the partial derivative of L with respect to W1, and the partial derivative of L with respect to, oh, you missed that for all of these, to B2, W1, B1. Okay. So those four partial derivatives are what I'm hoping to achieve. You literally can't see them. There you go. Those four partial derivatives are what we're looking to calculate. And because of the chain rule, the W2 ones, we're going to see a pattern when we spell it all out. And I'm hoping that pattern is the Hardman from VaultChat's notes. So let's do W2 is this is equal to the partial derivative of L with respect to A2. And then this is a vector, and it's just L with respect to each of them. That's completely fine. We're all happy with that. Times partial derivative of A2 with respect to Z2 times the partial derivative of Z2. Oh, I guess I didn't do superscripts for the weights, even though they capture layers. Whatever. Partial derivative of, oh, and then we're already here. Ooh, whoa, slow down. Oh no, that's true. Yeah, okay. Of W2. Perfect. That's what we want. And interestingly, what is this equal is, what's the shape of W2? It's a M by H matrix. What's the shape of this? This is what we did in the previous logistic regression. This is the stack of actually of A1s, A1 transpose. And then this is where we're actually going to do the Hardman, Hadamard. I don't know. I don't have the name yet. So these technically aren't scalar level. So in a way, this is the thing that I want to do shortcut wise, is I would write it like this, and then like this, and then because I'm told it's exactly the outer product between this and X transpose. Oh, so I still don't even write it like this. Let's see if I can take a moment. Let's try to apply the linear algebra. Let's see. I would write it as partial of L with respect to A2. Partial of A2 over C2. That's a vector. And then this is going to be multiplied outer product wise by A1 transpose. Oh, good, and it synced up for you. And this is going to be the outer product between the Hadamard, whatever, of this activation and Z into A1 transpose. Let's check with VaultChat if that generalizes how I'm expecting it to. Very unfortunately, today might not be a good video. But also, stand on business, you know what I mean? Like, this is also an opportunity for me to to do it despite the struggle, you know? So like a part of me like really wants to see it through. So, oh my goodness. Wait. This. I think that's what we've written. Guys, I think that's what we've written. This vector is L with respect to A. Hadamard. This is equivalent to A with respect to Z. Yeah. Fantastic. So that's the scalar. Perfect. So we do understand it. That's something we can be proud of. Let's see. Cool. What's next? So because, yeah, we can't, that's like, you know, I've said a few times of like, I need to practice deliberately that action of like how, how can I use these more advanced linear algebra tools instead of like accepting that like, oh, sure, that's equivalent, but like, are they in my toolkit to say, well, this does this, you know? Um, and this is far closer to recall than an application, even because it's the exact same shape, just different terms, you know? That's fine. So what about you with respect to B2? Is That's hard. Yeah, is part of me wants to break it down to the single variable case and then come back up to the Hademan Hardman case. You know, um, the single variable is what makes the most sense. Um, let's see, B2. Yeah, those all should have been written as layers because they're vectors. Yeah, let's see if we fix that. Let's fix that now. Yeah, because even if I wanted to do, how do I say? If I'd wanted to do W2, um, el element wise, how do I say? This is one, no, this is two. That doesn't make any sense. Let's see. It doesn't matter. This is one. This is two. I don't know why they're written in that order. But yeah, is if I had wanted to do it element wise, it would have looked weird because I already have a subscript. So notation is forcing us into this, which is why, you know what I mean? What do you do in the tensor case? I'm not, indexing, you know. I think layers and indices in a tensor are different. So like I think you could still do something like W index and then like, I don't know, how to say X, Y, Z. You know what I mean? I think that's still possible. It's like um the tensor in this layer and the tensor is across, I don't know, sequence length, G model, um, batch size. Yeah. Ooh man. Ooh man. Okay, how'd I get to B2? I want to do L with respect to let's see. I would argue, let's see, is we have this A1 here because um of W. That's the derivative with respect to W. But with respect to Z, I mean with respect to B, it's a scalar and that scalar is 1. So I would just copy this, you know? And let's see if does that shape align? I think it does. I think, yeah, like we should be able to leverage the fact that things are of repeated shape. Or that's like a, how do I say? It's a loose validation check. If I had to guess, you know what I mean? If I had to guess its derivative, you know, following the chain rule, we've gone all the way up to Z here. And again, you guys can barely see anything. We've gone all the way to Z there, and what's it called? We're the only difference is that I'm multiplying it by one more thing, and I would say what I would pause on is I'm using this sort of like, how do I say, cumulative property of multiplication as if we're working with scalars, but like it's not necessarily the same. I wonder if I could. Let's see. Okay, well, okay. Potentially, also let me see if I can speedrun this. To get to W1, what would I do? I have to go through A1, which means I would take the how do I say? I would take it from with respect to W2. No, 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 no. I would go through A1. It's L with respect to A2, A2 with respect to Z, Z with respect to A1 instead of with respect to W, and then A1 with respect to Z1, Z1 with respect to W1. So that is different. Let's see. L to A is fine, A to Z is fine, Z to A. What is the derivative of Z2 with respect to A1? Is the same thing as the derivative of Z with respect to X in the linear regression case. But we never did that. So this is vector with respect to a vector. If I were to split it out, Z is a vector. What I'm thinking is like Z is a vector. How is it affected? How is the vector of Z affected by each element of A? Let's focus on a single element in A and a single element of Z. That single element of A is actually going to be affected by a vector in W. Holy cow, is this where W transpose comes from? I would say Z with respect to A. Is Z with respect to A W transpose? W2 transpose. Z with respect to A. If I got that, I would call it a day. I'd say, oh my goodness, I realized it. Let's see. 4, 2, layer 2 sends the layer up through. To send the gradient back down to A1, you apply the Jacobian of that step, the denominator of W2. Okay, let me ask. Hey Tony, quick question. So for these backprop exercises, I'm looking at the neural network part, and I think I'm hopefully independently realizing the context of the W transpose for backprop. Is it because when we want to do the partial derivative of Z2, where Z2 is the untransformed operation from layer 2, Z2 with respect to A1 is actually W transpose.
You nailed it. That is exactly why the transpose appears. In the forward pass, you map the hidden vector A1 into the pre-activation Z2 using the weight matrix W2 answer, so Z2 is a 1. When you go backward, you are mapping the gradient from the output side back to the input side. By the rules of matrix calculus, the derivative of that linear step with respect to the input AA1 is the transpose W2 to It is the exact mathematical mechanism that carries the gradient backward across the linear layer.
Okay, yeah, that's good. That's good. That
It
did
is a
click.
really satisfying realization. Awesome. It is a huge milestone when that transpose transition clicks intuitively.
Um, that was good, you know. And like, funny enough, like for these videos, like,
It is a great feeling when that
whoa,
Oh, go ahead. What were you going to say about the videos?
you're gone now, right? That's not good. Um, for these videos, every like, kernel of like new information for Carl, fantastic, beautiful. Production for this one, really, really bad. Are we live? We're not even live anymore. It's so delayed. I have a lot that I want to do over the weekend. There's so many things I'm claiming that I'm going to do over the weekend. That piece of information is good. We have yet to complete the neural network version. I'm glad we kept going, I guess. But I haven't really seen it all the way through. What am I missing? So the handoff for layer 1 is the L with respect to Z. That's how we're going to define it. The upstream gradient. Let's see. Oh my goodness. This is pause. I'm unsure on this part. This is weird because this is Z with respect to A. I don't like the order that operation is being done. So that's part of what I don't like is, and maybe like the multiplication like lines it up, but basically that's the partial derivative of Z2 with respect to A1 times the partial derivative of L with respect to Z2. Perfect. Hadmond to respect of the partial derivative of A with respect to of A2. Wait, frick. No, that doesn't work. Because we're trying to go backwards, not forwards. So that's times the partial of A2 of A1. That's A1 with respect to Z1 being Hadamond with the partial of interesting. It's all the way up until, yes, it's all the way up until that. And then we have, um, okay, so I have this. This is fine. This is the A1 with respect to Z1. That's right before, we get the actual L with respect to Z1. But in order to get this, we need what's before A1. We need Z2 with respect to A1, which is this. And then we need L with respect to Z2 in order to have L with respect to Z1. Okay, and this is L with respect to Z2 to help us get L with respect to Z1. Okay, but the order is it's L with respect to Z2 to the left because it's like to the transpose of what's it called? Thingy with respect to Z1. I mean, of A. But it's It's Z2 with respect to A1. Z2 with respect to A1 times L with respect to Z2, which is why it's weird that they're flipped, but it's a transpose. Something's going on there. That is good though. You know what I mean? I think like not long ago in the video I was saying like, oh, I don't know what this is saying. I should be able to see what this is saying. I'm starting to see what this is saying, and not in the way that I was expecting it to. Um, yes, and this is what I say. This is my goal. That would be it. Add a second hidden layer. Yeah. Yeah. Okay. Very rough. And almost very much something that totally could have been done in like one video, and it would have been a lot better because I don't want to do a neural network again. But I'm gonna do the neural network tomorrow because I'm gonna go home. Let's see. Tool introduced here. Residual connections as a fork. Forward pass. XQVKV. Scores. Probabilities. Mixtures for multi-ed. Whoa. That's a lot. Yeah, these are a lot of things to get the partials for. Scores. Your input. N by D. Query key. DK. What are we saying DK is? I really like this. This is sequence length by D model. This is the way that I've been representing everything. I'm going to ignore batch size and all that kind of stuff. Single batch. Batch size is 1, and we haven't split for n heads. So batch size is 1. Batch size sequence length D model. And you do like D model n heads when you go all the way to 4. So we're fine. It's a matrix. Perfect. Ascendance is a matrix. Which really makes LLMs like a tangible thing. Like, really like that. QKV, how they're defined. Yes, that's fine. Attendance scores is fine. I understand their shapes. Okay. Oh, I understand their shapes, and at the end of the day, they're all matrices. They're all matrices still. Oh, crap. One head. Yeah, but going all the way to this, you have a dot 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 before L. Or so what am I taking before L, you know? And how do I say it? Softmax? Um I was purposely doing mean squared error because its derivative was so easy in my head. Yeah. How worthwhile is this? I think this is a really. I want to do this. I want to see it through, and I want to learn the algebra, linear algebra, and I want to practice it. But I have limited time. This is fun for me, but it's not me building anything or reproducing any papers. I must start building. Point blank. I think I can argue that it may be worth it for me to take a break from this and to just go into the code before this, because this isn't going to help me with the code. It's not as if the stronger my understanding on this, the stronger my understanding for the code. They're in parallel and they converge when it comes to me wanting to design my own architecture, but they're separate for now. So the me building my own architecture and having like deeper like mathematical foundations, amazing and important. Countless facets in which that's worthwhile. But my stated goal is the reproduction, which means code. So I don't think I'll be revisiting this immediately tomorrow. There may be things that I do off camera for sure. Because the vibe coding on camera does not necessarily make sense. But I think a video and like the whole thing with the iPad not being in sync is a serious bummer. The what's the flow? Architecting. I don't know. But so many things for if I were to write a spec doc, I think this is something I should do entirely as much of it as I can by hand. But no, by hand is still not necessarily valuable. So these are the things I'm thinking about. I'm thinking, okay, what if actually the iPad version, this also had a microphone and I was speaking out loud what I'm thinking is important, and then that sort of got like whisper flowed into like a document of what I think I need for architecting an LLM run with Coconut and that kind of stuff. And then I formalize that, and then that gets judged with respect to actual Coconut. You know, a video of me typing that out, that's just slower. That's not strictly better. Me speaking it out loud is faster than me writing, but still quite similar in terms of the cognitive demand. So writing should be done by me speaking. Writing should be done by me speaking. And then yes, it's like I want to document what I'm going to build. You know what I mean? It's like I need how do I say? I need a data loader. I need a this function and this function, this function, and this function. As far as what I can remember, what I think of. And then yeah, that information that I give the iPad, voice and drawing, I want that packaged by an AI into my coherent thought, put into like a markdown sort of thing for which I can then review and say, is this what I was thinking? Is this not what I was thinking? And then have that graded. Like the process of like the speaking in video being processed by AI, that's like a whisper flow orchestration transformation, not a processing adding, you know. I'm not asking for it to correct any of my statements. Yeah. So I need to start architecting a run, you know, because PyTorch is going to do AutoGrad. It doesn't help for me to know that, you know, like it really doesn't. So let's get into the code. Let's get into the code. Shell commands, you know, SSHing into Lambda compute, that type of stuff. Code. Spec docs and code. Spec docs and code. Spec docs and code. So code is what I'm going to read off cam. Code I read and review with AI off cam, and then I come back and I record myself building my spec doc from what I understand after reviewing the code myself very boringly. Okay. We're gonna stand up on our feet. We should be excited. I should be excited for tomorrow. We're gonna make it good. And I'm gonna go hang out with my girlfriend now.